Okay, today we're going to be looking at matrix operations. In this unit, we will be learning how to solve a system of equations by using matrices. So the first couple of lessons in this unit, we're going to just be doing the basics of a matrix. So it says a matrix is a rectangular array of numbers. Those numbers inside of a matrix are called elements. And they're enclosed by brackets. So anytime you see numbers surrounded by brackets, that's called a matrix. Okay, so your matrix will represent rows by columns. So your rows are your horizontal, and then your columns are your vertical. So it says the order of a matrix. The order is the same thing as the dimensions. Are defined by the number of rows and the number of columns. So that's how you find your order. The order that you write it in, it says it's written as rows that X represents by columns. So you're always finding out how many rows you have and then how many columns you have. The order of matrix A, so count how many rows you have. There's 3. So a 3 by, and then 2 columns. So 3 by 2 would be the order of matrix A. Looking at matrix B, your rows are horizontal. So that comes first. So there's 2, and then there's 3 columns. So that would be a 2 by 3. A 3 by 2 and a 2 by 3 are not the same thing. Okay, it has to be in that order, rows by columns. Matrix C, this is a fraction here, so that represents one element there. So you have 2 rows, so that would be a 2 by, and then 1 column. So 2 by 1 would be matrix C. So that's how you find your order or your dimensions of a matrix. Find the number of rows, find the number of columns. It's rows by columns. Some special matrices that we will look at later on in this unit. A zero matrix means that all of the elements are zeros. So notice the order is written here. It's a 2 by 2, which means you would have 4 zeros. A zero matrix that's a 2 by 3, you would have 3 and then 3 there. So a total of 6 elements. The identity matrix, which we will really use whenever we're solving the system. Identity matrix of a 2 by 2, your diagonal from left to right are 1s. Everything else are zeros. So on a 3 by 3, your diagonal from left to right will be 1s, and then all the other elements will be zeros. So those are some special matrices that you might see in this unit. All right, now we're going to get into what we're doing on the lesson today is adding and subtracting matrices. To add or subtract 2 matrices, their order must be the same. Okay, so you have to find the order of each matrix, and then if those are the same, you'll be able to add or subtract them. So example 1, find your order of each one. This is a 2 by 3. This is also a 2 by 3. Notice the order is exactly the same, so we will be able to add those 2 together. To add 2 matrices, you're going to add the corresponding elements, which means in the same position. So this top left element, we will add with this top left element. So when I add 1 plus 3, we get 4. 3 plus 1, we get 4. -2 plus a -5, we get a -7. And then continue with that on the second row. So that's 4 plus 0, which is 4. 0 plus a -7 is a -7. And then -5 plus 2 is a -3. When you're adding and subtracting 2 matrices, your answer should be the same order as the 2 matrices that you started out with. So notice we have a 2 by 3 there. Now, subtraction can get a little tricky because you're subtracting when you're dealing with negatives. So make sure that you pay close attention whenever you're subtracting. So same thing with adding and subtracting, you're making sure that the order is the same. So both of them are a 2 by 3, so we will be able to subtract them. So we will do 1 minus 3, subtract, that's a -2. We'll do 3 minus 1, which would be be 2. We'll do -2 minus, that is a -5. Make sure you subtract a -5, which would make it plus. So you would end up with a +3 there. 4 minus 0, which is 4. 0 minus a -7, which would end up giving you a +7 there. And then the last one, -5 minus 2, which would give you a -7. So make sure that you're paying close attention whenever you're subtracting, especially when you're subtracting negatives, that's going to get plus. Okay? You should end up with the same order, and that is our answer is a 2 by 3. You're adding and subtracting. Okay, example 3. Notice the order on this first one is a 2 by 2. The order of the second one is a 2 by 3. Notice they are not the same. You will not be able to add them together because if you're looking at your corresponding, there's not that third column that you can add. And you can't just put zeros in that third column of the first matrix in order for it to work. So this is not possible if those orders are not the same. So you can write not possible or abbreviate to NP. Not possible. Okay, example 4 looks a little different because we have a number on the outside of your matrix. This is called a scalar. When you have a scalar, which is the number directly in front of your matrix on the outside, you will distribute that to all of your elements on the inside, which means you'll be multiplying this -2 by every element inside that matrix. Your order should be the same as your original matrix. So when you distribute, you get -4, 6, -6, and -8. So you're just multiplying that scalar by all of your elements on the inside. Example 5, we're going to follow order of operations, which is PEMDAS. So P represents parentheses. So that's what you're going to have to do first is get rid of your parentheses. So I'm just going to bring down that 6 in that matrix. Do one step at a time. I'm going to bring down that -2, and then I'm going to open my bracket. The bracket is not the same thing as parentheses here because the bracket represents your matrix. So I'm going to do what's inside our parentheses. So notice we're adding 2 matrices. Remember we talked about on the front. We'll just add the corresponding elements. So 1 plus 5, we get 6. 0 plus 2, we get 2. 5 plus 7, we get 12. 3 plus 3, we get 6. 9 plus 9, we get 18. And 4 minus, or plus a -4, we get 0. So we got rid of the parentheses. E represents exponents. Notice we don't have any exponents. M represents multiplication. Notice we do have some multiplication because we have some scalars, which means that we have numbers on the outside of our matrix that we're going to distribute on the inside. So when we distribute that 6, that's going to be 36, 24, 54, -18, 30, and 66. Now this part right here, pay close attention. Notice we have a 2 in front of this matrix and it's -2 because we were subtracting. So if you go ahead and distribute -2 to all of those, then you'll be ending up adding those 2 matrices together. If you do not want to distribute the negative, just distribute the +2, then you can bring down your subtraction sign. So you can do either on that part. You should end up with the same answer no matter which way you do it. Okay? So when you distribute the -2, that would be -12, -4, -24, -12, -30, and 0. And so our last step, we don't have any division, but we have some addition. We're going to be adding those 2 matrices together. Notice that they have the same order. So when you add, you get 24, 20, 30, -30. Negative 6 and 66. So notice the order of your answers, the order of all your other original matrices that you started out with. Okay, last part. We're going to be finding the value of x and y. Notice that these two matrices are equal. If they are equal, that means that their corresponding elements have to also be equal if they're the same matrix. So that means x plus y has to equal 7. So I'm going to set up that equation. Notice 3 does equal 3. X minus y has to equal 1. And then notice 5 does equal 5 there. Okay, so we have two equations that we have here that we're trying to find x and y. Notice both of them have an x and a y, so we're not able to just solve for one. Okay, so we will either have to use, we have a system, which means two or more equations. We'll have to either use substitution or elimination. Notice if we were to combine these two, this y's would automatically eliminate. So I'm going to use elimination. So adding these two, that would be 2x. Y's cancel, and that equals 8. So x would equal 4. So we found x. To find y, we're going to plug it back into one of these other equations and solve. So y would equal 3. To check your answer, you can plug those back in. X plus y needs to equal 7. So 4 plus 3 does equal 7. X minus y needs to equal 1. 4 minus 3 does equal 1. So you can plug those back in and check it. Make sure that's the correct x and y. Okay, example 7 is a little different than 6 because it says we're adding these two matrices and then that will equal this element, which is 5, 6, 3, and negative 1. So remember, when we're adding, we add the corresponding. When they're equal, it equals the corresponding element. So that means 2x plus 3 needs to equal 5. Another equation that we can set up is 4x plus y needs to equal 3. You can also check 8 plus a negative 2 does equal 6. Negative 6 plus 5 does equal a negative 1. So you can just check and make sure that those are true there. Okay, notice on this one that we have our first equation only has an x. So I'm just going to solve for x on that first equation. So x would equal 1. And then I can use this second equation to plug in for x, and then I can solve for y. So y would equal negative 1. You can check it. 2 times x, which is 1, so that would be 2, plus 3 does it give us 5. 4 times 1 is 4, plus a negative 1 does give us 3. So you can plug those back in and check it. Okay, so today we were just adding, subtracting matrices. Also, we were given two matrices that were equal. We were finding x and y. And then tomorrow we'll actually start multiplying the matrices together.